Babies, welcome to our first video lesson on current electricity. So up to this point, you guys should have done a couple labs on introducing circuits using that online simulation. So what we're going to kind of talk about today is kind of concluding all that stuff about what's required within a circuit and kind of what goes from there. So the very first thing that we need in any sort of circuit is a energy source. So that's what's called voltage. So think about voltage as our source of energy that's going to allow charge to flow. So all voltage sources, like the one you guys were using in the simulation, was like a battery. So how a battery works is that you have a positive end of the battery and a negative end of the battery, okay? And as we hopefully remember from our unit on static electricity, that if I have a positive charge and a negative charge, that it's going to create an electric field that would look something like that. And what that means is that if charge is placed within this field, the charge is going to move from the positive end of that field to the negative end. So why we have a battery that creates a positive and negative terminal is that in that positive and negative battery, once we give charge a path, so if I were to connect something here and connect something there and give charge a path to flow, that charge is actually going to flow from the positive and come back towards the negative, but it's going to flow through the external part, which is called the circuit. Okay, so the main thing that we first need within our circuit is what's called a voltage source. The voltage source is the source of energy. It creates the electric field, which then allows charge to move. And that's part of what we're going to talk about today is the energy part of things, is how charge gets energy. Because when we talked about energy, we talked about both potential energy and kinetic energy, okay? So in this case, when we talk about voltage, voltage is going to be a description of the potential energy of charge, okay? It's very similar to how we viewed things in terms of masses, but now we're dealing with the small scale level on charge. All right, so voltage in general is just a description of how much potential energy you're going to give to charge at a certain part of that electric field, okay? The way we measure voltage is through the unit called a volt. Okay, so it's pretty simple. So you'll see, for example, I don't know, maybe 9 volts for a battery. Okay, what 9 volts means is it's a description of how much energy it's going to give to charge. So a volt is technically defined as a joule of energy for every 1 coulomb of charge. So for example, if I have a 9-volt battery, 9 volts means that I'm giving 9 joules of energy to 1 coulomb of charge. Now, 9 joules of energy is not a lot from our perspective, but when it comes to charge, which is very small, that's going to be quite a bit of energy that we're giving to charge. So voltage is a description of the potential energy that we're going to give to something. Now, the idea we got to think about is that with voltage, it's all about what's called potential energy. Potential energy is energy being stored, not being used yet. And then if we remember that when we use energy, it naturally gets turned into kinetic energy. So we talked about the same principle in terms of gravity, that let's say I have the ground here and I take an object and I lift it up. That when something has a lot of height in, let's say, a gravitational field, it's going to have a lot of potential energy. Because this object wants to naturally, because of the gravitational field, wants to naturally be pulled down by gravity. Gravity is going to do work on that object to pull it down. Okay, so at this point, it doesn't want to be in the air, it wants to be down on the ground. So in this case, it has a lot of potential energy because it's at a location that it doesn't want to be. And then if I naturally let go, it's naturally going to fall to a spot where it has low potential energy. But remember that as it does this, it's going to flow to a point that when it has low potential energy, it's going to have high kinetic energy. Okay, and if I wanted then to reverse this process, if I wanted to take an object from a low potential energy and bring it back up to a high potential energy, that means that I would have to lift this thing up. So how does this relate to charge? It relates the same way. Think of a battery, okay, where we have the positive terminal and the negative terminal. The positive terminal is where we're going to have a location of high potential energy, and the negative charge parts, we're going to have a position of low potential energy. Now, where again we have high potential energy is where we're going to have low kinetic energy. And where we have low potential energy, we're going to have high kinetic energy. And the purpose of the battery is to continually cycle charge through. So it's going to look very similar to this, that inside of a battery is going to do work to try and give charge potential energy so that it will move again. Okay, so the battery is actually the thing that's doing work, which is why when we use a battery or some sort of voltage source, kind of heats up because it's actually doing work, like if we were to do work to lift something up. Now again, how does this relate to charges? So we talked about an electric field. So for a positive charge, right, its electric field is directed outward, okay? So very similar to kind of how gravity works. If I were to think of this positive charge, a positive charge does not want to be by another positive charge. So the farther away a positive charge is, that means here it's going to have low potential energy because it's at a spot where it wants to be. But if I were to bring a charge closer, this is going to be a location where it has high potential energy. So if I were to naturally let go of this object, it's naturally going to flow from the positive to the negative. Okay. In this next diagram, if I were to have negative charges, again, its field is directed towards that charge, which means it wants to pull things in. So if I take A, which is a positive charge, and put it at A, this charge wants to be near the negative. So I put it at a location where it doesn't want to be. So here's where it has high potential energy. And when it gets close to the negative charge, it's going to have low potential energy. But the key thing, again, is that when it has low potential energy, it's going to have high kinetic energy. So kind of putting these two things together, what you're going to see in a circuit is a combination of B and D, where it's going to have a location of high potential energy at the positive terminal and low potential energy at the negative terminal. But then keep in mind, where it has low potential energy is where it has high kinetic energy, and the opposite would be up here, okay? So that's what we're trying to do with a voltage source, is give charge energy to flow. Now, when charge is able to flow, what's going to happen is obviously that energy that's being given to it by the battery or the voltage source is then going to be used by charge and is used throughout the circuit. Okay, so looking at simple circuits which you guys created, let's say that I had a 1.5 volt battery. 1.5 volts, again, is going to be a description of how much energy that charge is going to have. At the positive terminal is where it's going to have high potential energy, and at the negative terminal is where it's going to have low potential energy. So that means in order to go from high potential energy to low potential energy, energy's got to be taken away somewhere. So as the charge goes from A to B, it crosses the wire. It's then going to go through a bulb and cross from C to D, another wire. As it crosses a wire, okay, wires are made of pretty good conductors, so there really isn't much energy lost through a wire. There might be some, but normally it's close to zero. So the voltage from A to B across the wire is going to be the same. But what happens when you go from B to C is that we obviously have a light bulb, and a light bulb is designed to take that energy away from the charge. So the charge reaches B with a lot of energy, and as it goes across to C, all that energy is going to be taken away. And then its goal is to then flow through C, and again, when it has low potential energy, it's got a lot of kinetic energy, it's going to flow through C to D, and then the battery's goal is to recircle this thing back through, or recycle it back through. Okay, so what happens as we go throughout the circuit is that the voltage is going to, keyword here, is going to drop. What we call this is a voltage difference, or the fancy word for it's what's called an electric potential difference. Keyword there is that word potential. It just shows that as we go across different points within the circuit that the voltage is going to change. Now, if I were to throw, let's say, a second bulb in here, okay, what's going to happen is, let's say I give it 6 volts, that from A to B, voltage will be the same, but what will happen from B to C is that 6 volts, some of that potential energy is going to be transferred, taken away to C, and then as it crosses the wire again, as it gets from D to E, crosses that second bulb, the voltage again is going to drop. Okay, so every time it crosses a component other than a wire in a circuit, the voltage is going to be taken away. Think of that as energy being used. So the battery kind of gives the charge energy to flow, and then the objects within the circuit are going to take that energy away. All right, now one of the things you guys had to do in the labs was you had to look at, okay, if voltage is all about providing energy for charge and making it move, how do we maximize the amount of charge we can give something? So we can do this with our battery source. So obviously in a household circuit, we have outlets that we can plug things into. We can use batteries. Those are kind of designed differently. Obviously an outlet is not the same as a battery. Okay, so if let's say I wanted to increase the voltage of a battery, one thing you guys had to practice with was aligning batteries in different ways. There are 2 ways you can align batteries. One is called a series and one is called parallel. Series is when you line the batteries up from positive to negative. Okay, so understand when you see these, the left end would be negative, positive, and then notice I got negative, positive, and then negative, positive. So notice what's happening here is I'm lining up the positive of one end to the negative of the other. Same thing here. What it essentially does is notice that the other ends, I have a negative end over here and a positive. So what it essentially does is it creates a larger battery with one positive and one negative. So hopefully you guys saw that if I have a series voltage source, that the voltage is simply going to add up. So 9 plus 9 plus 9 would actually create a total voltage of 27 volts versus a parallel connection. Parallel, you're connecting the positive to the positive to the positive and the negative to the negative to the negative. Okay, so if I look at this as an overall battery, I still have a single battery with a positive and negative terminal, which means the voltage doesn't change. It's going to stay at 9 volts. Now, what would be the benefit of having something in parallel? The benefit of having batteries in parallel is that we are providing a longer lasting energy, that 9 volts is being supplied by 3 separate batteries. So if one were to go out, we still have voltage being provided by one of the other batteries. Okay, and I challenge you guys that if you, let's say, a good way to look at this is possibly go into at home if you have a remote control that requires 2 batteries. Sometimes they will have you guys line up the batteries within something. It might have you line up the batteries opposite. Like it might be positive to negative, positive to negative. So you'll see the batteries kind of flipped upside down. This would technically be, because we're connecting positive to negative, this would actually be a series alignment. But you might sometimes see them lined up side by side where both positive ends are towards each other. So I have positive to positive, negative to negative, that because I'm lining it up like that, this would be a parallel circuit. So sometimes we line up batteries within devices to create more voltage, or sometimes we want longer lasting voltage. All right, the last thing to talk about for today is that once we have a battery source, obviously the next thing we need, a battery's not going to do anything. Outlet's not going to do anything unless you plug something in. So we're going to actually need a path for charge to flow. So we create the energy, which then we have to give to charge, and then we need to provide a path for charge to actually flow. So the second lab you guys had to look at was what was required of the path that we need. So what we're going to call this is a CCP. It's called a closed conducting path. So first word means closed, is that the word closed in electricity means that there's no gaps in our circuit. So for example, in the diagram down here, this would be an opening. So this circuit would be said to be open, and this diagram here would be said to be closed. Closed means that there's no gaps, and once the circuit is closed, we should have a nice flow of charge. But however, when we have a closed circuit, we also have to make sure that everything that's a part of that circuit has to be some sort of conductor, whether it's a really good conductor or maybe it's like some sort of semiconductor or whatever it might be. Okay? A conductor, again, why that's important is that a conductor allows for the flow of charge. So charge will actually flow through the wire, through the bulb, through the wire, and through the batteries. And if you notice, everything in a circuit is made of some sort of metal. Right? Think of the wires are made of normally copper. You'll see on the batteries, you might have a shiny metal end on both sides. Even in a light bulb, you'll see the little metal filament on the inside. That everything's made of metal because metal allows for the flow of electrons. And we also have things wrapped in plastic because plastic is an insulator that we want to keep the flow of charge within the circuit and not have to go anywhere else. So it's got to be closed, and it has to be a closed path of conductors. When that happens then, charge is said to flow then from the positive terminal. It's going to flow through each component, the wire, then through the bulb, then through the wire, and then back through the battery till it goes there. And know that charge will always flow within a circuit from the positive terminal to the negative terminal of the battery. Okay? Now, we'll talk about a little bit more on that in terms when we get to our second section on current electricity, on current. But in terms of the path, this is what we need, is we need a closed path of conductors in order to produce that flow of charge from positive to negative. All right, so 2 key details from today. First thing we need is a voltage source to provide energy, and then we need a closed conducting path in order for charge to flow. Once that happens, we will get the flow of charge. So the next thing we're going to look at is what happens with the flow of charge. Okay? Once we have a flow of charge, our goal then is to control it so that we can use it. And that's going to be what we're going to focus on in our next couple sections. Guys, got any questions on this stuff? Make sure you ask, reach out to me. We can go through some things with that, okay? All right, good luck. We'll talk to you guys later. Goodbye now.